Mars, often called the Red Planet, has always been a world of mystery and fascination. For centuries, people have gazed up at the night sky, wondering what lies beyond our own world. Ancient civilizations told stories about the stars, and modern scientists have studied Mars relentlessly. But despite all the advances in technology and exploration, the Red Planet has kept its secrets. Few people understood just how hard it would be to uncover these mysteries. It wasn't until the early 21st century that humankind took a serious leap toward unraveling Mars' hidden truths. In 2011, something extraordinary happened. The world's attention shifted to a single, powerful yet small machine, the Curiosity rover. This wasn't just any robotic vehicle. It was designed to be a scout, a pioneer sent to a world far away, in search of answers to some of the most important questions humans have ever asked. Is there life on Mars? Did water once flow on the planet's surface? Can humans ever set foot on Mars? It all started with a desperate call. Scientists at NASA had been pushing for a mission that could answer these questions. For years, they had launched satellites and smaller rovers, but none had come close to achieving what they hoped for. The Mars Science Laboratory (MSL) mission, with Curiosity as its centerpiece, was different. It wasn't just about sending another rover. It was about sending the most advanced, ambitious rover ever built to Mars. Before Curiosity, space missions to Mars had failed or delivered limited results. The challenges of landing on Mars were terrifying. The planet's thin atmosphere meant there was almost no air to slow down a spacecraft as it descended to the surface. Scientists had to figure out a way to land safely on a surface covered in dust storms, extreme temperatures, and harsh conditions. For years, they had been perfecting this technology, but in truth, no one was sure if it would actually work. And then on November 26, 2011, it was time. The world watched as the Curiosity rover was launched from Earth aboard a powerful Atlas V rocket. The mission had begun. A daring journey of more than 350 million miles was ahead, but this was only the first step in a long and dangerous mission. As Curiosity hurtled through space, it faced numerous challenges. There were moments when scientists felt uncertain, when the long journey through space seemed endless. The rover's systems were pushed to their limits, and every twist and turn in its path brought new risks. What if something went wrong? What if the rover missed its landing? There was no turning back. The suspense grew with every passing day. The mission's success or failure would hinge on one critical moment, the landing. For over 8 months, the Curiosity rover traveled toward Mars at unimaginable speeds. The moment of truth was drawing near, and with it, the desperation for success. If the landing failed, years of hard work would be lost in a heartbeat. NASA engineers and scientists had worked tirelessly to perfect a landing system that had never been attempted before. But even with all their hard work, no one knew for sure if it would succeed. The Skycrane landing method was bold, risky, and untested. The world's eyes were fixed on Mars, and as the rover approached the planet, the tension reached a peak. On August 5, 2012, as Curiosity began its final descent into the Martian atmosphere, the entire world held its breath. This was no ordinary landing. This was the moment that would define the mission. As the rover plummeted toward Mars, it had to survive the terrifying 7 minutes of terror. During this time, the rover would be on its own, with no communication from Earth. It was up to the rover to complete the landing sequence without any assistance from mission control. Inside NASA Jet Propulsion Laboratory, engineers and scientists anxiously awaited the rover's fate. Would it survive? Would it land safely on Mars? The clock ticked down, and the mission's future hung in the balance. Back on Earth, millions of people were glued to their screens, hoping for success. But it wasn't just about science. It was about something more. It was about human ambition, our desire to explore, to push the boundaries of what is possible. Curiosity was more than just a robot. It was a symbol of humanity's unyielding curiosity and our never-ending drive to discover the unknown. As the minutes passed, the world held its collective breath. And then the moment came. Curiosity touched down on Mars safely and successfully. The cheers from NASA team echoed around the room, a mix of relief, pride, and excitement. The rover had made it. Against all odds, it had landed on Mars. This was the beginning of something extraordinary. Curiosity had arrived on the Red Planet, ready to begin its mission of exploration. But even as the rover began its work, the desperate call of Mars echoed in the background. The planet was still full of secrets, mysteries that could take decades or even centuries to solve. But Curiosity had arrived to begin unraveling those mysteries. And so, as Curiosity started its mission, the world couldn't help but wonder, what would it discover? What new knowledge would it bring back? Could Mars once have supported life? These questions were just the beginning. What the rover found would change everything we knew about Mars. But first, it had to face the Martian landscape, a world so alien, so different from Earth, that every move it made would reveal something new and surprising. The journey had only just begun, and already the world's most daring experiment was proving that humanity's reach could extend far beyond Earth. The desperate call of Mars had been answered, and curiosity was ready to uncover the planet's deepest secrets. One discovery at a time. The success of Curiosity's landing on Mars was a monumental achievement. It was a triumph of engineering, science, and human determination, but the real work was only just beginning. For the world, the moment of landing had been a collective sigh of relief, a brief moment of celebration. But for the team at NASA, this was only the beginning of a journey that would stretch across years and change the way we understood Mars forever. Once Curiosity had safely landed in the Gale crater, a region of Mars that scientists had carefully selected for its potential to hold the secrets of the planet's past, the rover's mission took a new turn. Its purpose wasn't just to take pictures or send back simple data. It was meant to search for the building blocks of life, investigate Mars' history, and determine if the planet could have ever supported microbial life. But how would a machine, no matter how advanced, be able to reveal something so profound about a planet so distant, so hostile? The team had designed Curiosity to do things no rover before it could. Equipped with a range of powerful tools and scientific instruments, the rover was capable of analyzing rock samples, studying the composition of the soil, and even drilling into Mars' surface to uncover secrets buried deep below. The first few days were crucial. The rover began to send back its first images of Mars. To the scientists, these weren't just pictures, they were pieces of a giant puzzle that could change everything. Every new image sent back from Mars was another clue in the mystery, but the real challenge lay ahead. What would the rover find? Would it find evidence that Mars had once been habitable? Or was it a lifeless world that had never supported life at all? Curiosity's first stop was an ancient rock formation in the Gale crater. It wasn't just any rock, it was a remnant of Mars' past. Scientists had suspected that these rocks held the key to understanding the planet's early history. After all, Mars had once been very different. Billions of years ago, it was a warmer, wetter planet with rivers and lakes. But somewhere along the way, it lost its atmosphere and its ability to support liquid water. How and why did this transformation happen? And more importantly, could the signs of Mars' once habitable past still be found? As Curiosity drilled into the rock, the team back on Earth waited with bated breath. For the first time in history, a machine was peering beneath the surface of another world. When the results came in, the scientists were stunned. The rover had found something extraordinary, evidence of ancient water. Not just water, but signs that Mars had once had the right conditions for life to exist. In the soil, scientists found chemicals that were essential for life as we know it, elements like sulfur, nitrogen, hydrogen, and oxygen. They were there waiting to be discovered, hidden in the Martian rocks for billions of years. This was the first real breakthrough of Curiosity's mission. It was proof that Mars wasn't always the dry, cold desert that it is today. At one point in its history, it was a place where life might have existed. This discovery didn't just shift the focus of the mission, it raised new questions. If Mars had once had water and the right chemicals, could it have supported life, even on a microbial level? If so, what happened to that life? Could some form of life still exist beneath the surface, hidden from our view? But Curiosity's mission wasn't just about water and the search for life. The rover had a broader mandate, to learn about the Martian environment, its atmosphere, and its geology. It was exploring Mars in ways no one had ever done before, using cutting-edge technology to study the soil, air, and rocks. With each discovery, the mystery of Mars deepened. Curiosity's next big breakthrough came when it studied the planet's atmosphere. While Mars' thin atmosphere couldn't support life as we know it, Curiosity detected traces of methane, an important clue. On Earth, methane is a byproduct of biological activity, and its presence on Mars suggested that there could be some form of ongoing processes happening beneath the surface. Scientists weren't sure what that meant, but it opened up new possibilities for exploration. Could there be active processes on Mars today? Could there still be life, hidden in the planet's icy depths? The suspense built as the rover continued to explore. Curiosity's findings weren't just academic, they were changing the way scientists thought about life beyond Earth. With every sample it analyzed, the rover was showing the world that Mars wasn't just a lifeless rock in the sky. It was a place with a dynamic history, a place that could have supported life, and perhaps even still could. Back at NASA Jet Propulsion Laboratory, the excitement grew with every new discovery. But they were also aware of how fragile this mission was. Mars is an unforgiving place. The rover had to deal with dust storms, radiation, and temperature extremes. Curiosity systems were put to the test every day, and even the smallest malfunction could have jeopardized everything. But the rover pushed on, sending back valuable data, keeping its systems running, and continuing its journey into the unknown. Curiosity was also becoming a symbol of human exploration. People around the world were fascinated by its discoveries. The rover's findings were not just of scientific importance, they were inspiring. They sparked imaginations, fueled the desire to explore, and encouraged people to think beyond Earth. For many, curiosity became a reminder that with enough ingenuity and persistence, we could uncover the mysteries of distant worlds. But the journey wasn't. Mars still had many secrets to reveal, and curiosity, with its amazing technology and unwavering determination, was the perfect tool to uncover them. Each discovery brought more questions, and with each question the hunger to know more grew. The more curiosity revealed, the more the world wanted to know. As curiosity continued to roll across the Martian surface, it wasn't just exploring a distant planet. It was paving the way for the future of human space exploration. Mars, once seen as an unreachable world, was now a place within humanity's grasp, and curiosity was leading the charge, opening up possibilities that had once seemed impossible. The rover's journey was just beginning as curiosity continued its exploration of Mars. Its discoveries became more and more profound. What started as a mission to explore the surface of the red planet quickly evolved into something much larger, a deeper investigation into Mars' ancient history, its environment, and the potential for past or even present life. But despite the rover's remarkable successes, Mars still held its secrets tightly, refusing to give up its deepest mysteries easily. The more curiosity uncovered, the more it became clear that the answers would require a deeper dive into the Martian soil and atmosphere. Curiosity's primary task was to gather clues about Mars' ability to support life. With its sophisticated suite of instruments, the rover began investigating the planet's surface for signs of past habitability. As it ventured deeper into the Gale crater, it encountered strange rock formations that hinted at a turbulent past. For billions of years, these rocks had been shaped by wind, water, and the harsh Martian climate. What had these rocks witnessed? What had they experienced in Mars' distant past? One of Curiosity's key objectives was to study the ancient riverbed layers within the Gale crater. These layers were more than just stones. They were the planet's history written in rock. As Curiosity drilled into the rocks, it was like unlocking a time capsule, sending back data that suggested Mars had once been a very different place. Scientists had long suspected that Mars had once hosted flowing water, but now they were beginning to gather tangible proof. The rocks that Curiosity analyzed contained minerals that could only have formed in the presence of liquid water. These minerals told the story of a time when Mars might have had rivers, lakes, and even a thick atmosphere capable of supporting life. However, this discovery didn't answer all the questions. While the minerals in the rocks suggested Mars had once been a more hospitable place, the rover's findings also pointed to something even more curious. As Curiosity dug deeper into the layers of rock, it found signs that Mars' once thriving environment had suddenly and dramatically changed. What had caused the planet to lose its atmosphere and dry out? Was it a natural disaster, or was there something more mysterious at play? Curiosity's next major breakthrough came when it began studying the planet's climate. The rover's weather sensors allowed scientists to monitor Mars' temperature, pressure, and atmospheric conditions in real time. Over time, the data revealed something startling. Mars' atmosphere was incredibly thin and the weather was harsh and unpredictable. Dust storms, sometimes lasting for weeks, could cover the entire planet, blocking out sunlight and making it nearly impossible for Curiosity to operate. But despite the challenging conditions, the rover pressed on, providing valuable insights into how the planet's atmosphere might have once been more Earth-like, with a thick protective shield that could support water. Mars' atmosphere, it seemed, had been stripped away over time, likely by powerful solar winds from the sun. Without that protective atmosphere, the planet became a frozen, arid world, incapable of supporting liquid water on its surface. The more Curiosity revealed about Mars' atmosphere, the more scientists began to understand why the planet's climate had shifted so dramatically. The sudden loss of atmosphere, along with the planet's weakened magnetic field, had led to Mars' slow transformation into the cold, desolate place it is today. Despite these dramatic changes, Curiosity's data was uncovering more evidence that Mars may not be entirely dead. The rover detected small amounts of methane in the atmosphere. On Earth, methane is often produced by biological processes such as bacteria or animals. This discovery raised new questions. Could there be microbial life hidden beneath the surface of Mars producing methane? Or could the methane be the result of some unknown geochemical process? Either way, the discovery of methane added another layer of mystery to the already complex puzzle that was Mars. Curiosity's findings were starting to challenge the traditional view of Mars as a barren, lifeless world. If there had once been water and a more hospitable environment, could life have existed there at some point? Could there be life beneath the surface today, waiting to be discovered? These questions lingered in the minds of scientists as they carefully analyzed the rover's data. While Curiosity had given them a wealth of information, it had also raised even more questions about the nature of Mars' past and its potential for supporting life in the future. As the rover pressed on, its journey took it to new regions of Mars, each offering a glimpse into the planet's hidden past. Curiosity visited sites where ancient volcanic activity had shaped the landscape, revealing clues about Mars' geological history. The rover's drill made its way into rock formations that were once molten and solidified millions of years ago, providing insights into the planet's early geological processes. Every layer of rock, every sample analyzed, was like a page in Mars' ancient diary, waiting to be read. But even as Curiosity made incredible strides in understanding Mars' history, it also faced the harsh realities of exploring a planet so far from home. Dust storms, unpredictable weather, and constant technical challenges tested the rover's systems every day. Yet with each challenge, Curiosity continued to deliver new information that deepened our understanding of Mars. For the scientists on Earth, it was as though they were slowly piecing together a giant jigsaw puzzle. With each new discovery, the picture of Mars became clearer, but at the same time, the complexity of the planet's history only grew. Mars was no longer just a dead world. It was a place with a dynamic, mysterious past, one that could hold answers to some of humanity's biggest questions about the potential for life beyond Earth. The rover's findings were changing the way people thought about space exploration. Mars was no longer an impossible destination. It was a world waiting to be understood. And Curiosity, with its perseverance and determination, was leading the way. As it roamed the Martian landscape, drilling into rock, analyzing soil, and studying the atmosphere, it was unveiling secrets that could shape the future of human exploration, and perhaps even our understanding of life itself. The rover had one more task ahead of it, one final mission to gather evidence that could bring us closer to answering the biggest question of all. Could Mars support human life? But before that, Curiosity would continue to dig, explore, and send back data, unraveling the deep, dark secrets beneath the red planet's surface. One discovery at a time. As Curiosity continued its journey across the Martian surface, its mission evolved into something far more profound than anyone could have anticipated. What had begun as an ambitious exploration for signs of past life became a quest to unlock the mysteries of Mars' ancient past. Each new discovery, each rock sample, and each piece of data seemed to open up more questions, forcing scientists to reconsider everything they thought they knew about the red planet. Mars had long been regarded as a desolate, cold wasteland, an uninhabitable world abandoned by time. But Curiosity was proving otherwise. The rover's exploration of the Gale crater uncovered something astonishing, evidence of an ancient Martian climate that might have been much warmer and wetter than scientists had previously imagined. One of Curiosity's most remarkable discoveries came when it encountered a section of rock that revealed a history of water flow. These ancient rocks, now dry and cracked, had once been shaped by rivers, much like the ones on Earth. The layers of these rocks told the story of a planet that had once experienced a climate similar to Earth's, a planet with lakes, rivers, and perhaps even seas. It was a moment of revelation for the scientific community. Mars, long considered a barren world, had once been a place where water flowed freely on its surface, shaping the land and creating an environment that might have been capable of supporting life. The rover's advanced tools, including its drill and its array of spectrometers, allowed it to analyze these ancient rocks with incredible precision. Curiosity's data revealed that the minerals in the rocks were rich in clay, an essential ingredient in the development of life. Clay forms in water, and its presence in Mars' ancient geological record was a strong indicator that liquid water had once existed there for extended periods. These findings changed the narrative about Mars. It wasn't just a dry, dead planet. It had once been alive with water, with the potential for life. As Curiosity ventured deeper into the Gale crater, the rover discovered further evidence of Mars' watery past. The rover's instruments detected compounds in the rocks that suggested Mars had once hosted a thick atmosphere capable of trapping heat, allowing liquid water to remain on the surface. Scientists had long suspected that a thick atmosphere had once existed on Mars, but these new discoveries were the first clear evidence that the planet had once been a much more hospitable place. Mars wasn't always the frozen, barren world that it is today. In its distant past, it might have had a climate very similar to Earth's, with the potential for life to evolve. Yet with every discovery, there was still a lingering mystery. What happened to Mars? Why did the planet lose its atmosphere and its ability to support water? The more Curiosity dug into Mars' geological layers, the more these questions arose. What event or series of events could have caused such a dramatic shift in the planet's climate? Could Mars' transformation into a cold, dry world have been sudden, or did it happen over millions of years? Curiosity's exploration of the Gale crater continued to shed light on this question. The rover's cameras captured stunning images of rock formations that told a story of gradual change. The layers of sediment that Curiosity encountered were evidence of a slow, gradual shift in the planet's climate. As the rover drilled deeper into the rocks, it uncovered clues that suggested Mars' climate had been stable for a time before undergoing a dramatic transformation. The planet's atmosphere, once thick and capable of supporting water, had gradually thinned over millions of years, leading to the dry, inhospitable world we see today. But the mystery didn't end there. As Curiosity continued to analyze the surface of Mars, it began to uncover signs of geological activity that suggested the planet was still evolving. The rover detected signs of recent volcanic activity, with volcanic rocks scattered across the Martian landscape. These rocks provided clues to the planet's geological history, suggesting that Mars might still be experiencing tectonic shifts beneath the surface. Could the planet still be alive in a geological sense? Was Mars undergoing a quiet transformation, one that could eventually make it habitable once again? Curiosity's findings sparked a new wave of excitement among scientists. The rover was uncovering clues about Mars' past that had been buried for billions of years. But more than that, it was challenging the way we think about the planet. Could Mars have been a cradle for life? Was there a time when it supported ecosystems, however primitive? And if life had once existed on Mars, could it have left behind traces that were still buried beneath the surface? As the rover continued its mission, it became clear that the discoveries it was making were not just about Mars. They were about the possibility of life elsewhere in the universe. If Mars had once supported water, if it had once been capable of sustaining life, what did that mean for the rest of the solar system? Could there be other planets or moons out there, waiting to be discovered, that might have had similar conditions in the past? And could some of them still harbor life today? The more Curiosity revealed, the more it became evident that the search for life on Mars wasn't just about the red planet. It was about answering a much larger question. Is Earth the only place in the universe where life exists? Mars, once seen as a cold, lifeless world, was now emerging as a key player in the search for extraterrestrial life. Curiosity had opened the door to a whole new realm of possibilities. Its discoveries were just the beginning of a larger, ongoing mission to understand Mars and its potential for life, past, present, and future. Every day, Curiosity rolled across the Martian surface, uncovering more and more of the planet's secrets. It wasn't just about finding answers. It was about opening new avenues of exploration, of discovery, and of understanding. As the rover continued to explore the Gale crater, scientists knew that they were standing on the precipice of something extraordinary. Mars had given up some of its deepest secrets, but it was clear that the planet still held many more. And so, the search for answers continued. With each sample, each new piece of data, Curiosity was uncovering a new chapter in Mars' ancient story. It was a story of water, of climate, of life, and of the possibilities that awaited humanity in the stars. As Curiosity moved deeper into the Gale crater, the rover's wheels left behind tracks in the Martian dust, marking the path toward understanding an ancient world. It was becoming clear that the red planet had once been much more than the desolate, dry desert it appeared to be today. But with each step Curiosity took, a new puzzle piece was put in place, and Mars' story began to unfold, not just as a cold, distant neighbor, but as a world that may have once been teeming with possibilities. Curiosity's next breakthrough came when it analyzed a particularly unique area within the crater, an ancient layer of rock, shaped by time and possibly water, that scientists had been eager to explore for years. This was no ordinary rock formation. The patterns etched into the surface told a story of Mars' violent past, but also a period of relative calm. As Curiosity carefully drilled into the layers, it unearthed a new revelation. Mars had been shaped by far more than just water. It had been subject to frequent, large-scale environmental shifts, such as volcanic eruptions and massive dust storms, which might have created periods of instability. Yet, buried within this chaos were signs of resilience, hints that life, even in the most rudimentary form, could have once survived there. One of the most fascinating discoveries was hidden in a pocket of clay, a relic of the planet's early days. The clay contained trace amounts of organic molecules, complex carbon-based structures that are essential to life. These molecules were not proof of life itself, but they were the building blocks. On Earth, such compounds are often the first step in the creation of life. Their presence on Mars sparked an exciting question. Could Mars have been a cradle for life? Could these compounds have been the foundation for something much bigger? To understand the full implications of this discovery, scientists began to look at Mars in a new light. The red planet had always been considered a one-off, an anomaly in the solar system. But now, there was a possibility that Mars had shared a similar origin to Earth in some ways. Could the two planets have once shared the same early conditions for life? As Curiosity's instruments continued to analyze the clay deposits, it became clear that Mars might have been more than just a place that lost its water. It might have been a world on the verge of something extraordinary. Yet, as the rover uncovered more, it also brought with it a growing sense of melancholy. The mystery deepened. If Mars had once had the right conditions for life, why had it changed? What went wrong? Why did Mars lose its ability to sustain liquid water? And why did its atmosphere collapse, turning the planet into a frozen shell of its former self? Curiosity's exploration wasn't just a scientific mission. It was a meditation on the fragility of planetary environments. It was a reminder of how vulnerable a planet can be, how easily it can lose the very factors that make it habitable. For the team back on Earth, it wasn't just about analyzing rocks and soil. It was about understanding the delicate balance of conditions that allow life to thrive, and the consequences of losing that balance. As Curiosity rolled through the Martian landscape, it continued its work, investigating ancient riverbeds and analyzing the atmosphere. But the rover's exploration was beginning to take on a deeper, more philosophical meaning. With each new discovery, the scientists were reminded that Mars wasn't just a dead world. It was a world that had lived, that had changed, and that might still hold the potential for life even today. As they looked at the planet's surface, they couldn't help but wonder, what could have been? The rover's instruments detected tiny bursts of methane once again, an anomaly that could signal the presence of microbial life beneath the surface, or even more intriguing, some form of geological activity that remained hidden to human eyes. While methane on Earth is often a byproduct of life on Mars, it remained a mystery. Was it being produced by ancient microbial life, or was there an unknown, non-biological process at play? The possibility that there might still be active processes on Mars, geochemical or biological, was both exciting and unsettling. The question now wasn't just about what had happened to Mars, it was about what might still be happening. As Curiosity ventured farther, it entered the area scientists had marked as the most intriguing region of the Gale crater. The rover was getting closer to Mount Sharp, a massive mountain that rose 5.5 kilometers above the crater floor. Mount Sharp was more than just a geological feature. It was a time capsule, holding layers of sediment that recorded the entire history of Mars. The rover had arrived at a pivotal moment. The layers at the base of Mount Sharp were rich in clay minerals, just like the earlier deposits Curiosity had analyzed. But these layers were even older. The deeper Curiosity drilled, the further back in time it could reach. And with each passing day, scientists could peer deeper into the Martian past. Curiosity's job wasn't just about sending data back to Earth, it was about reshaping our understanding of Mars. The rover's findings were leading to a complete reassessment of the planet's history. No longer was Mars seen solely as a dry, dead world. Instead, it began to take on the character of an ancient, complex planet that had undergone dramatic shifts but still held the potential for discovery. The findings from the Gale crater hinted at a world that had been far more dynamic than anyone had imagined. Mars might have had a liquid water cycle, with seasons, clouds, and perhaps even rains at one point in its history. It was a planet that had weathered extreme environmental changes, and yet despite those changes, it might have once nurtured life. The deeper Curiosity traveled, the more it became apparent that this wasn't just about Mars. The rover's discoveries were reshaping the framework for how we think about other planets. Mars was no longer an isolated case. The clues it revealed about ancient climates, water, and the potential for life had opened the door for even more questions about the habitability of other worlds in our solar system, and beyond. Perhaps one day, Curiosity's journey would lead to even greater answers. Perhaps the mission would prove that life could have once existed on Mars, or maybe even that traces of life still linger beneath the surface, hidden from our view. But for now, as Curiosity ventured further into the Gale crater, it was already changing everything we thought we knew about the red planet. Mars was no longer just a distant curiosity in the night sky. It had become a story of change, of loss, and of the unknown possibilities that await us in the stars. And as Curiosity sent back its data, scientists and dreamers alike could only wonder what the next chapter of this extraordinary journey would reveal. As Curiosity continued its trek across the desolate Martian landscape, it became more than just a machine. It became a silent witness to the planet's history, an instrument capturing whispers of a long-lost world that once might have been filled with the promise of life. Each mile it covered, each new discovery it made, opened a window into a time when Mars could have been an entirely different place, a world not so different from Earth. But as Curiosity pressed forward, Mars remained elusive, revealing only fragments of its past in scattered clues. In the vast expanse of the Gale crater, Curiosity encountered an eerie silence, one that seemed to echo through the vast emptiness of the planet. It was as though Mars itself was holding its breath, revealing its secrets piece by piece, as though it were testing humanity's resolve, daring us to dig deeper, think bigger, and look beyond the surface. Curiosity's journey took it across vast alien terrains, dry riverbeds, jagged rock formations, and expansive plains of dust and sand. But it wasn't just the terrain that was changing, it was the rover itself. As it moved further into the Gale crater, Curiosity encountered challenges that no one had expected. The conditions on Mars were harsh, and the rover's systems were beginning to show signs of wear. Despite this, Curiosity continued its mission with unwavering determination, continuing to send back vital data about Mars' atmosphere, geology, and climate. Then Curiosity reached an area scientists had been eagerly anticipating, an ancient mudstone formation that held the promise of even more profound revelations. Mudstone on Earth is a sedimentary rock that forms in still, shallow water, and its presence on Mars was nothing short of extraordinary. Scientists had long suspected that this kind of rock could hold the key to understanding Mars' past and whether the planet could have supported life. As Curiosity drilled into the mudstone, it revealed something unexpected, evidence that Mars may have experienced rapid climate changes, periods of violent storm activity, and even sudden shifts between wet and dry conditions. These discoveries painted a picture of Mars not as a static world, but as one that was in constant flux, its environment fluctuating dramatically over millennia. It was a world shaped by powerful forces, flooding, erosion, and perhaps even volcanic activity, that had reshaped its landscape many times over. Mars wasn't just a planet that had lost its way. It was a planet that had experienced tumultuous changes, leaving behind a scarred history. The mudstone samples were filled with tiny, delicate layers that could tell the story of a world in transition. As Curiosity's instruments scanned the rock, scientists were able to discern not only the presence of minerals that had been formed in water, but also signs of ancient climates. It was as if the rover had uncovered a Martian version of the Earth's history book, one that told of warm, wet periods, where water flowed freely across the surface, only to be followed by cold, dry times. These discoveries painted a picture of Mars' climate that was much more complex than scientists had originally thought. The rapid shifts from wet to dry may have been responsible for the planet's transformation into the barren desert it is today. But the more Curiosity discovered, the more it raised new questions. Was this just a planet that had gone through cycles of growth and loss, or was there something deeper at play? Could the sudden changes in climate have been triggered by some catastrophic event, perhaps an asteroid impact or the gradual loss of the planet's protective magnetic field? As scientists pored over Curiosity's findings, they found themselves drawn into a deeper mystery. What caused the transformation of Mars from a wet, warm world to the frozen desert we see today? This question would not be easy to answer, but Curiosity was unrelenting in its pursuit. With each new sample, the rover continued to reveal fragments of Mars' tumultuous past, each piece adding to the growing picture of a planet that had experienced life, perhaps even harbored life, but had lost it through time. Yet there was still hope. Mars had not yet given up all its secrets. The rover's data suggested that beneath the planet's barren surface, something might still be alive or at least dormant. The discovery of methane once again was a key clue. In addition to the clay deposits and ancient rock formations, Curiosity detected unusual bursts of methane. This chemical compound, often associated with biological processes on Earth, raised an intriguing possibility. Could methane be produced by microbes, still living deep beneath Mars' surface? Or was the methane a result of an unknown geological process, perhaps linked to Mars' volcanic history? Whatever the cause, it added a new layer to the mystery, one that suggested Mars might still harbor some form of life, hidden from view, surviving beneath the surface. Despite all these groundbreaking discoveries, Curiosity's journey was far from over. With each passing day, the rover continued its trek, moving toward Mount Sharp, a towering peak in the heart of the Gale crater. Scientists hoped that the deeper Curiosity ventured into this ancient mountain, the more they would learn about Mars' geological evolution, and perhaps its ability to support life. But there was another, more pressing question that was now on the minds of many scientists. Could humans one day walk on Mars? As Curiosity uncovered clues about the planet's past, the possibility of future human exploration seemed more realistic. If Mars had once been habitable, could it be made habitable again? Could humans, with their advanced technology, terraform the planet and create an environment that could support life? While these ideas remained speculative, the discoveries of Curiosity had already paved the way for further exploration. Mars, once seen as a distant and uninviting world, was becoming something more, a potential destination for future explorers, a place where humanity might one day set foot. And Curiosity, with its quiet determination, had been the key to unlocking the mysteries of that world. It had traveled farther than any previous rover, revealing secrets that had been buried for billions of years. As Curiosity rolled across the Martian surface, scientists back on Earth marveled at the discoveries that were unfolding. Every day brought new data, new insights, and new possibilities. Mars, once an enigmatic red dot in the sky, was now a world waiting to be explored, not just by rovers but by humans as well. And so Curiosity's journey continued. The rover had become more than just a machine. It had become a bridge to the future, a link between the past and the possibilities of tomorrow. It had uncovered the echoes of a lost world, and in doing so, it had shown humanity that Mars wasn't just a world of dust and rock. It was a world that had once lived, and might one day live again as Curiosity continued to explore the surface of Mars. Its mission evolved into something beyond the initial scope. No longer was it simply about gathering data and taking pictures. The rover had become humanity's eyes and ears on a distant world, unraveling the mysteries of a planet that had once held the potential for life. Each discovery added layers of complexity to our understanding of Mars, and yet it also left behind an unsettling question that seemed to echo in the silence of the Martian landscape. Could Mars still be hiding life beneath its surface? Mars was no longer just a cold, dead planet. With Curiosity's findings, it had transformed into a world of possibilities. The rover's scientific instruments had already uncovered clues suggesting that liquid water once flowed across the surface, that the planet had once hosted a thicker atmosphere, and that conditions could have been conducive to life. But despite these groundbreaking discoveries, there was still something hidden, something subtle, almost imperceptible, a pulse beneath the planet's surface that scientists couldn't fully explain. The most intriguing sign of this hidden pulse was the continued detection of methane in Mars' atmosphere. On Earth, methane is often associated with living organisms, particularly microbes. The presence of this gas on Mars had sparked a debate that would continue to captivate the scientific community. Could the methane be a signature of life? Curiosity, with its advanced tools, continued to monitor Mars' atmosphere for signs of methane and other gases. The rover's data hinted at fluctuations, methane levels that seemed to spike at certain times, only to drop again. This wasn't a steady, predictable pattern like that of a simple chemical reaction. It was a signal that something more complex might be occurring below the surface. Some scientists believed that the methane could be linked to microbial life that was still active in Mars' subsurface. Perhaps these microbes were thriving in pockets of water trapped beneath layers of rock, surviving in the harsh conditions that most would deem inhospitable. Others speculated that the methane could be the result of geothermal processes, where ancient volcanic activity was releasing trapped gases from Mars' rocky interior. Whatever the cause, this discovery was no small thing. It added an entirely new layer to the mystery of Mars, one that suggested the planet might not be as dead as it seemed. Curiosity's data continued to fuel this tantalizing possibility, and with each passing day, scientists grew more convinced that Mars might still be harboring secrets, both ancient and ongoing. But Curiosity's work wasn't limited to searching for signs of life. It had also become an investigator of Mars' past, a planetary detective piecing together the planet's long and tumultuous history. The rover's exploration of Mount Sharp, an imposing peak in the center of the Gale crater, was like turning the pages of a planetary journal. Each layer of rock the rover examined offered a glimpse into a different chapter of Mars' story, from ancient riverbeds to periods of intense volcanic activity, to the slow drying up of the planet's once thriving environments. One of the most compelling finds was in the layers of clay-rich rocks at the base of Mount Sharp. These rocks suggested that at one time, Mars may have been a much wetter and warmer place. The layers seemed to tell the story of Mars' transition from a potentially habitable planet to the cold, arid world we know today. The rover's instruments identified minerals that only form in the presence of liquid water, evidence that Mars' surface had once hosted vast bodies of water, such as lakes or seas, for extended periods of time. In addition to these geological discoveries, Curiosity continued to observe the weather on Mars. While the planet's thin atmosphere was incapable of supporting human life, it was not without its own unique weather systems. Mars experienced dust storms, some of which could cover the entire planet for weeks, blocking sunlight and disrupting the rover's operations. But it was during one of these storms that Curiosity made another groundbreaking observation. Mars was still an active planet, subject to the forces of nature that shaped its surface over millions of years. The storms, along with temperature fluctuations, and the interaction between the atmosphere and the planet's surface, provided a dynamic environment that challenged the idea of Mars being a lifeless, static world. Curiosity's observations of the Martian atmosphere were just as revealing. While scientists had long suspected that Mars' atmosphere had once been thick enough to support water, the rover's data confirmed that the atmosphere had gradually thinned over time, possibly due to the loss of its magnetic field and the stripping away of its gases by solar winds. This process had caused the planet to lose its ability to retain heat, turning it into the frigid desert it is today. Yet, despite the harsh conditions, Curiosity found signs of hope, of Mars' ability to change, adapt, and perhaps even hold onto secrets. As it roved across the Martian surface, it continued to search for clues that might explain the planet's transformation. The rover's findings painted a picture of a world that had undergone incredible change, but one that still held the potential for further discoveries. With each sample collected, every scan of Mars' surface, Curiosity was rewriting the story of the Red Planet, a planet that might not be as dead as it appeared. For scientists, Curiosity's mission was no longer just about answering the question of whether life ever existed on Mars. It had become about understanding the planet's long, complex history and the forces that shaped it. Mars was a world of extremes, extreme weather, extreme conditions, and extreme transformations. But it was also a world of hidden potential. Could Mars once again become a place that supports life, either in its past or its future? Curiosity's journey was not just a scientific exploration. It was a journey that brought humanity closer to the stars. It had shown that Mars was not simply a barren rock in space. It was a world with a history, a story of climate change, water, and the possibility of life. And while the search for life continued, Curiosity was also revealing something equally important: the nature of exploration itself. Every step the rover took was a reminder that even the most hostile environments could hold answers, and that the drive to explore, to discover, and to understand was what made us human. Mars was no longer just a mystery. It was a world waiting to be explored, and Curiosity was its first guide. As the rover continued its quiet work, the pulse of Mars, the hidden rhythm beneath its surface, reminded us that exploration is not about conquering new worlds, but about understanding them in all their complexity, mystery, and potential. As Curiosity ventured further into the Gale crater, the mission began to transcend the realm of science and entered the domain of human imagination. The rover's discoveries had already shaken the scientific community and provided answers to questions that had long been unanswered. But there was a deeper, more profound question that remained unanswered. What does the future hold for Mars? Mars had already become a place of history and mystery, with Curiosity's findings opening a window into a past that might have been as dynamic and life-sustaining as Earth. The evidence of ancient water, the shifting landscapes, the layers of rock that revealed the evolution of the planet, all of these discoveries told a story of a world that could have been very different from the barren, dry desert it is today. And yet, Mars still holds a unique position in the hearts of scientists, dreamers and explorers alike. There was a promise, a hope that Mars could be something more. Could humanity one day reach the Red Planet not just to study it but to live there? The possibilities were as exciting as they were daunting. Curiosity was helping to shape the future of human exploration by unveiling Mars' secrets, but the rover's work was just the beginning. The next step in this journey wasn't just to understand Mars. It was to make Mars a home for humanity. Could we live there, breathe its thin air, and survive in its harsh conditions? Could we build a world that could support human life once more? For years, NASA and other space agencies had been developing plans to send humans to Mars, but these ambitions were always tempered by the sheer scale of the challenges involved. Mars' atmosphere is 100 times thinner than Earth's, and it contains very little oxygen. The planet is constantly bombarded by radiation, and its surface temperatures fluctuate wildly, making it a hostile environment for life. Yet with every discovery Curiosity made, the dream of living on Mars seemed to edge closer to reality. The next frontier wasn't just about exploring Mars remotely, it was about stepping foot on its surface. Humans have long dreamed of walking on other worlds, but Mars seemed the most promising candidate for the first human colony. Thanks to Curiosity, scientists had learned about the Martian soil, its weather patterns, and its geology. They had discovered that while the planet's surface is inhospitable, there are resources hidden beneath the soil that could support future colonies. The presence of water in the form of ice could be critical for life support. It could be used for drinking, growing food, and even producing oxygen. And yet Curiosity's mission was not just about discovering resources. It was about teaching humanity how to approach the unknown. With each discovery, the rover showed that the path to Mars would not be easy. The rover's data underscored the reality of how difficult it would be to survive on Mars. The atmosphere's lack of oxygen, the frigid temperatures, and the dust storms that could last for weeks posed significant challenges. But Curiosity also revealed something equally important. Mars wasn't entirely hopeless. It was a world of potential, a world that could, with the right technology and the right approach, be turned into a new home for humanity. Every day, Curiosity's wheels turned on Mars' surface, collecting data that would be invaluable to future human missions. It wasn't just about the rocks and soil, it was about the big picture: how to adapt to a new world, how to make Mars hospitable for humans, and how to overcome the challenges of living on a planet so far from Earth. Curiosity wasn't just collecting information, it was laying the groundwork for future explorers. Every piece of data sent back to Earth was helping to answer the fundamental question of whether Mars could ever be transformed into a second home for humanity. One of the most important aspects of the mission was understanding the Martian climate. By studying the planet's dust storms, temperature fluctuations, and seasonal changes, Curiosity was helping scientists understand how to design habitats that could withstand the harsh Martian conditions. Could future astronauts live in pressurized habitats? Could they grow crops in greenhouses? Could they find ways to generate power and oxygen from the Martian environment itself? In many ways, Curiosity's mission was a prelude to a larger, more ambitious goal. With each discovery, we learned more about the tools, technology, and systems that would be necessary for a sustainable human presence on Mars. It was a gradual process, each step building upon the last. Curiosity wasn't just about gathering data, it was about shaping the future of space exploration. It was teaching humanity how to survive on a world that, just a few years ago, seemed utterly inhospitable. The discoveries made by Curiosity have already sparked a new era in space exploration. Companies like SpaceX and organizations like NASA are actively working on spacecraft, rovers, and habitats that could one day transport humans to Mars. But while Curiosity was uncovering the secrets of the Martian past, these organizations were looking to the future. The question now was no longer just about what Mars was, but what Mars could become. Mars has always been a symbol of human ambition, the idea that we could reach beyond our planet and become an interplanetary species. For generations, people have looked up to the red planet, imagining what it would be like to stand on its surface and look back at Earth. Curiosity's discoveries have made that dream feel more tangible, more achievable. While we are still a long way from sending humans to Mars, the rover's findings have provided the roadmap for the future. But Curiosity also showed something else. The journey to Mars isn't just about the destination, it's about the journey itself. It's about the quest for knowledge, the drive to explore, and the courage to face the unknown. Every discovery Curiosity made, every challenge it overcame, reminded humanity that space exploration isn't just about the technology we use. It's about the spirit of curiosity and discovery that drives us forward. As Curiosity continues to explore, it serves as a reminder that the journey to Mars is a long one, but it is also a journey filled with potential. The rover has already shown us a world full of mysteries, challenges, and wonders. And with every step, we get closer to the possibility that one day, humans might walk on Mars and gaze up at the same stars from an entirely different world. The dream of tomorrow is closer than ever. Thanks to Curiosity, the red planet is no longer just a distant dream. It is a world waiting to be explored.